We are recording. So, any questions?
Yeah, I have two. The first for the master set on problem number 2,
Right?
what does, what does that indicate? Does that indicate if acceleration isn't constant or if acceleration isn't 0? For this notation.
The acceleration is not 0.
Okay, so what does, so for me, I was thinking, okay, like if I'm changing direction, or let's say I'm moving around a curve,
Correct?
in theory, I guess I could be moving around a curve at a constant acceleration, or maybe I'm moving around at a, or maybe I'm moving around at a constant velocity, which means that acceleration is 0. Like I guess. So I didn't know, does that count?
What is velocity?
Velocity is meters over time, like meters per second in a direction.
Okay, so if you're going around a curve, is your direction constant?
No.
Therefore, you're accelerating. Acceleration is not 0 if you're going around a curve.
Okay. And
Backwards acceleration.
then
Would it be backwards or acceleration?
It's actually centripetal acceleration, which is something that we'll get into.
sorry. And then the last thing is for the second lab for, oh, no, not this lab. For one-dimensional motion. Nope, sorry, for confirming functional relationships, sorry.
Okay?
You ask us in analysis B to use the line ST function to find the slope, right? But I was looking at the equation that you gave us, and I was thinking in my mind, isn't this an exponential curve? But the line ST only gives us the information for a linear function.
Right, it should be linear, because you're plotting, that's for the second one?
Yes,
Because you're plotting time squared, right? Isn't it time squared
Yes.
versus distance or
Yep.
displacement? Because you're plotting versus time squared, you have a relationship of that the displacement is equal to 1/2 AT squared. So let's add the formality of it. VIT plus 1/2 AT squared. If acceleration is constant, we have this relationship here. In the lab, you started the ball off at rest, so this term goes to 0. And so what you're left with is this, that we have a relationship between delta x, and if you plot it versus time, you have a parabola of some sort, or a radical.
yeah,
Something along those lines. But if you plot versus time squared, this is now a single entity. And if acceleration is constant, we have a linear relationship.
okay, so, and also, we have to, when it's asked, like, for the constant portion of it, is that the half and the acceleration, they're both constants? So really,
Yes.
the only variable is the
First
time
off,
squared.
I hope the half is constant. If it's not, then we're all in big trouble. Okay,
So that, the only variable is the time squared.
and the displacement. And we have
Yeah.
the independent variable and the dependent variable.
Wait, time squared is the independent?
No, independent, dependent. The time depends upon the distance it rolled. Unless you were going, how far is it gonna go in 2 seconds? No, you did, how long does it take to roll, or whatever the distances you had.
So, does displacement, I know you don't like math terms, but like, does displacement go on the x-axis?
Yes.
So, that's, is dependent y or x? I thought dependent was y.
It is. This time
Mhm.
depends upon how far it rolled. So
Okay.
this is dependent.
Okay, that makes sense.
Okay.
Thank you.
Yep. Other questions? Jansen?
What's your preferred method of turning in the lab?
Correctly? Does that work for you?
Online or?
I guess what's becoming old school of, I like paper, but I understand environmental issues. So, either. Just so long, I mean, and it could even be mixed. I mean, if the spreadsheet's gonna have to be done online, that's preferred for the spreadsheet. For the rest of it, on paper is fine, or if you wanna somehow put it into one document to submit, I'm good with that too.
So you're fine if we turn in the paper and then just submit the Excel spreadsheet online?
Yes,
Okay.
yes.
For the analysis questions for the labs, is it okay if I like just number them and answer the questions and scan the PDF and turn it in?
Yes.
If that makes sense.
Yeah.
Okay. When you say submit one document to, is it okay, like, under the submission, if there's like, I've got my Excel file and then I've got my PDF with my analysis?
Yeah, that's fine, yeah,
Okay.
the one file, as in, I had a student in the first 8 weeks who, if there was a 10-page lab that she was submitting, it would be 10 different PDFs, one per page.
Oh, okay.
At least she numbered them, unlike some other students who would not number them and it would just whatever random generate.
Is that okay for the master set too?
Yeah. Other questions? Oh, okay. All right, so I'm not seeing Hector. And Jacob.
Jacob,
You're
yep,
Jacob.
not Jake.
Right, yep, no, I got Jake.
Wait, I have a question.
Oh.
So on the hints document for
Right.
chapter 2, there's like videos that you can watch, and they're like M4, M5, and I was wondering, where do you find those?
Are they, what, the videos?
Yeah, like on the hints document for like hints and like,
Alright, so if you go to the videos to watch for
Yeah.
chapter 2 under coursework,
yeah.
there's conceptual videos and then there's mathematical videos. So C is for conceptual, like C4 would be the conceptual
Yeah.
fourth.
Alright, that was getting me. I was really looking for like an M5 and like
Oh,
everywhere.
sorry about that.
Yeah, it's fine.
Your mind reading skills
Yeah.
apparently are weak.
Yeah.
No other questions?
Actually, can we turn in documents for like, let's say the master set 2, can I turn that in today?
Yeah.
Okay.
No harm handing things in early.
Okay.
And apparently no one's handing stuff in on paper, or if you are, you know, it goes into a stack based upon wherever the first person logically puts the first thing.
So we turn it now?
Yeah. Yeah. Whichever one works. Chances now established the pile.
And if we're submitting a problem like a spreadsheet, we can submit that online.
Yes, I assume the spreadsheet will be done online. Matter of fact, it should be, the spreadsheet should be submitted online. Because I do a cut and paste. The purpose of it is so I don't have to retype the numbers. Right, that long pause was if there were any other questions, not just my mind going off on tangent.
How does the testing procedures work? Like, when is our first test? Like, how's that gonna go?
Test will be in here. during this time. Did you want more detail?
No, I would like, you know when, or something.
There's something on the schedule there for end of next week for the first test, but we'll know better later.
Okay.
Yeah, I have to. Philosophically, you really should not be teaching a course to students you don't have, which means I need to know what this group is like in order to really have some idea of the pacing. But we have to have a schedule before we know any of our students. So I assume every schedule I ever produce will be wrong. But there is a schedule. So that should give you at least the earliest that it would be.
Thank you.
I did answer your question, right? Okay. Anything else?
I have extra sheets of paper. I'm only like running on like one right now, and I'm assuming because we have class today that it's gonna be longer than one piece of paper could
Yeah,
hold.
Here, I have a piece of paper you can use.
Thank you so much.
All right. Some of this should be, if you watch the videos, review or rehash. Quickly expand to this week. All right, the person standing out over a cliff throws the ball up into the air. Initial velocity, let's make up positive, because why not? Initial velocity is 30 meters per second. I want to know final velocity and time at the end. I do, but. Sorry? Oh. All right, and the answers are? All right, so with any of these problems, and it's going to especially apply to the projectile motion, thank you. We got five basic quantities. 6 depends on how you want to deal with displacement versus position. But typically you have position, velocity, initial velocity, final velocity, acceleration, and time. And so these are the basic quantities when you're dealing with constant acceleration problems. So first off, how do we know this is a constant acceleration problem?
Isn't gravity constant?
At what point do I start picking off the language? Let's start now. We do better than that.
Because the negative direction is constant?
No, that's not the reason why. I would hope that once you establish a problem that the negative direction would be constant regardless of anything else. Was it Chance who said the first? Okay. So I'm picking on the language here. What's constant?
Acceleration due to gravity?
Yeah, much better answer. Gravity, huge topic. Acceleration, just one small part of it. All right, so acceleration due to gravity officially, actually, technically is not constant, but it is close enough. The difference in the acceleration due to gravity on the top of this building and on the ground you would need multi-million-dollar equipment to find the difference, so it's close enough to constant. Let's assume that this is Earth. So what would the acceleration be?
What is it, 9.8 something, I think that's the.
Negative 9.8
Negative
meters per second
9.8
squared,
And why is it negative?
because we established that the up direction, or the direction opposite of gravity is positive.
Yeah, let's try to break ourselves of this idea that the word gravity is this catch-all for everything related to this, to gravitational force, gravitational acceleration, gravitational constant, curvature of space and time based upon gravitational pull.
We established that the direction opposite of the acceleration due to gravity is positive.
Okay, or opposite the force due to gravity.
Okay.
So negative 9.8 units,
Meters per second squared.
okay? What is it in feet per second squared?
I forgot.
You got me.
32.
Yeah, 32.2 I think it is, 32 point something. All right, so what else do we know? We actually need to know 3 things in order to solve for all 5, so what are the other 2 things we know?
Well, I'm assuming that V and then the one above VS in that list there, that was 30.
That's initial, that's a sub
Something over
I.
there where you listed all of them, the one above VS.
Oh, yeah, that's an I2.
Yeah.
Oh, okay, I was confused.
All right, so 30 meters per second. Now, I know that it is thrown upwards, not only because of the drawing, but because the fact that this is a positive number here. If I just said the speed was 30 meters per second, then there'd have to be some more information in order to know whether that was up or down. All right, and we have one other piece of information.
When the velocity final equals 0?
All right, it's a common thought because you're picturing it hitting the ground and stopping. Is that?
That's what I'm imagining, yes.
Yeah, so this is part of the language of physics. When you're saying final velocity, recognize that we are dealing with a constant acceleration problem. Once it hits the ground, or once it touches the ground, the acceleration is no longer constant because it's going to slow down very quickly. So we have the tools for determining our missing values, assuming acceleration is constant. So when I say what is the final velocity, that's common language in physics, but what we mean is the velocity just before it touches the ground.
Sorry, can I ask you a question?
Yes.
Usually, if there is no predetermined initial velocity and it's like just dropping, it's usually 0, right?
Right, if I use the term dropped, then you should assume 0.
Perfect.
Right. But there is one other piece of information
So
given the problem.
Wouldn't it be delta S,
Yes, what is it?
20 meters?
Negative 20 meters?
Negative 20 meters.
You get 2 very different answers if you have a positive or a negative there. Actually, yeah, we'll stick with 2. All right, so I have these 3 things. We've established it's a constant acceleration problem. So we have what I refer to as cake. So what is cake?
Constant acceleration kinematic equations?
Yep, there you go. So what are they? Can anyone do it without looking?
Unfortunately, no.
Your chance to show off, like, apparently. In unison would be really cool. All right, there's 2 equations that start with a VF, and there's 2 equations that start with a delta S. So the V equations, we have VF equals VI plus AT. We have VF squared equals VI squared plus 2A dot delta S. Please note, there's no vector symbol over these V's here. That is on purpose, because these are speeds. Then the two delta S's, we have delta S equals VIT plus 1/2 AT squared, which I wrote on the board earlier. And then the delta S is equal to average velocity times time, and if acceleration is constant, average velocity is just the first and final velocities average times time.
What is the S supposed to stand for?
The S with just a vector symbol would be position.
Okay.
You used X, Y, R. Yeah, any of those work. S comes from the Latin stadia, which was basically the ancient Roman line.
Okay.
I will usually write X, for some reason I'm in an S frame of mind. Okay,
So it doesn't matter what we use, or it does?
right,
Okay.
as long as you're sticking to X, Y, Z, S, or R, those are, something beyond that, I might go, what is this? Oh, okay, that's what it means. All right, do not use these equations if acceleration is not constant. So many times I've given a non-constant acceleration problem, people are cramming stuff into this. It makes it easy to grade, but very sad. All right, so what do we need to solve for time? Well, we could solve for final velocity first.
For final velocity, we could use the second formula.
Yeah, because we don't know time, so we need the equation that has final velocity in it, but not time. That would be this one. Occasionally I have students who panic and can't think about which one to do. Plug in all four and see which one has only one variable. But we have VF squared is equal to 30 squared plus 2